Okay, we're at gotomath.com working some algebra. We're looking at simplifying radical expressions, and it looks like we're going to be doing 7.1. 7.1. Right. Okay, so this time we've got 1 over the square root of x, and we want to get rid of this radical. We want to rationalize the denominator, I should say. All right. And so we're going to do that by multiplying the denominator by the square root of x. But if we do that, we got to multiply the numerator by the square root of x also. Okay. And so now we end up with 1 times the square root of x over x, right? Square root of x times square root of x is just x. Okay. Alright, let's take a look at another one here. Let's draw a divider line, or attempt to draw one. So this time we're going to have 1 over the square root of x to the 10th power. The square root of x, actually let's change that. The square root of x to the 9th power. Let's put an odd number there. Okay. So what I'm going to do now is I'm going to break this up into the square root of x to the 8th times x. And we'll rewrite this again, breaking this up. The square root of x to the 8th times the square root of x. Okay. And I'm going to get this out of radical form. Let's write this with the rational exponents. And that's going to end up being 1 over x to the 8th raised to the half times, and we'll go ahead and write this one too. Now of course 8 times a half is 4, so now this becomes 1 over x to the 4th times x to the half. I didn't have to write this with rational exponents, but I did anyway. But now you notice if we multiply x to the half, just pretend this is the square root of x, right? And then x to the half up in the numerator. Guess we'll write it right here. So the top, and you know what, I'm going to go ahead and convert back over to radicals here. And this, right, we'll keep x to the 4th down here. Now half plus a half, we add exponents when we're multiplying. A half plus a half is 1. So this is x to the 1st power, or just x. But we need to go ahead, we have x to the 4th times x to the 1st, and what do we do here? We add exponents, and so we're going to be left with the square root of x over x to the 5th power. X to the 5th power. All right. Okay, let's look at another one. Why not? So what if we had 2 over the square root of 12 times x to the 11th? So you want to pause the video and try to work that out yourself. Okay? Alright. So what I'm going to do here is I'm going to go ahead and break this up. Down here we're going to have, what all do we got here? For that square root of 12, I know that 4 times 3 is 12. Okay. And this, we're going to break this up as x to the 10th times x. Okay. Now what's going to remain under the radical is going to be the 3 and the x, because this is a perfect square. So let's go ahead and rewrite this. So we have the square root of 4. We have the square root of 10. It's not the square root of 10. The square root of x to the 10th, and then the square root of 3x. Square root of 3x. Okay. Alright, so now we've got 2 over. So the square root of 4 is 2. The square root of x to the 10th is going to be x to the 5th. So if you've watched some previous problems that I've done, you know why, right? Because this is x to the 10th raised to the half, and a half times 10 is 5. And then of course we got the square root of 3x. But we're not done. We've got to rationalize the denominator. We need to get rid of that radical out of there, and so we're going to multiply 3x over 3x. Right, and of course this is multiplication here. So this becomes 2 times the square root of 3x over, and now we have the square root of 3x times the square root of 3x is just going to be 3x. X to the 5th times 3x. Of course we need to clean this up down here. Now look at here, the 2's cancel out. Okay? 2's cancel out. So we're going to end up with square root of 3x yeah. No. Okay. What do we got? We got 3 times x, add exponents, 5 and 1, that's 6. That's 6. Okay, so that's what you should have left. Right there. Alright. So we're over here at gotomath.com getting it worked out. See you in the next problem.